So moving on to question 3, it says, which of the following explains what is happening when sodium is dissolved in water? So when we look at our structure for sodium, it's going to be NaCl, and water we know is H2O. So A is saying more hydrogen bonds are forming between water molecules. So this can't be true because we know that our sodium is being dissolved. If you pour table salt into water, it'll make a homogeneous mixture. And for something to be dissolved, the water has to interact with the other molecule. So there has to be some interaction between the water and the salt. If the water is just interacting with itself, that's not going to cause any dissolving. So B says sodium and chloride atoms are separating from each other. So this is true. When water and sodium meet, the sodium ions will be separated into Na and Cl, and they'll float around in the mixture separately, and the ionic bond between them is broken. So this is true, but when we look at C, it says hydration shells are forming around sodium and chloride ions. So C is actually our answer because it's saying that our sodium and our chloride ions are separate, and then it's also giving us the relationship to water. So the water will then surround all of the ions, and that's what's going to make it dissolve and be homogeneous in the mixture. If we look at D, it says covalent bonds are breaking and reforming. So this can't be true because our NaCl is ionic. So between the Na and the Cl is what's known as an ionic bond. A covalent bond is a different bond. So D cannot be true because it's not a covalent bond being broken and reformed, it's an ionic bond.